Could we colonize the big cratered moon Callisto? In this video, we will deal with Callisto, one of the main moons of the gaseous giant planet Jupiter, and we will try to understand if its hypothetical future colonization is feasible or not. Callisto, together with Io, Europa and Ganymede, is one of the Medicean satellites and was discovered by Galileo Galilei on January 13, 1610, who reported his observations in his work Sidereus Nuncius. These satellites are called medicean because the Italian astronomer dedicated them to Cosimo II De Medici, his benefactor. Galileo observed the Medicean satellites with a very rudimentary telescope and with a very small field of view. Even today, one wonders how he managed to discover them, given that in this very small field of view, they could hardly see all four at the same time. In Greek mythology, Callisto was a nymph, or according to other versions, the daughter of King Lycaon or of one of his sons, Cadus or Nyctus. She was one of the handmaids of the goddess Artemis, Diana for the ancient Romans, whom Zeus seduced because he was attracted by her beauty. According to some versions, inspired by the homonymous comedy by Annis, an Athenian playwright and poet, Zeus transformed himself into Artemis in order to attract Callisto and lie with her. As a result of this intercourse, she became pregnant, and when she was discovered, she was expelled and turned into a bear by Artemis or Hera. As a bear, she then gave birth to Arcade, the eponymous hero of the Arcadia region. In the last part of the myth, just before being killed by an arrow of her son, who had mistaken her for a normal bear, Zeus saved her life by placing her among the stars like the bear Cratered. With a diameter of 4,818 kilometers, Callisto is the third largest moon in the solar system after Ganymede, diameter 5,264 kilometers, and Titan, diameter 5,150 kilometers, Saturn's main satellite. In practice, Callisto is larger than our moon, which has a diameter of about 3,475 kilometers and slightly smaller than the planet Mercury, whose diameter is 4,879.4 kilometers. The surface area of Callisto is 7 times smaller than the area of the Earth's surface. The circumference of Callisto is equal to 15,000 kilometers, the terrestrial one to 40,000 kilometers. The fastest airliners on Earth travel at 850 kilometers per hour. It would take 2 days to travel the entire circumference of the Earth, while on Callisto, this time would amount to just 17 hours. Would you like to try this experience? Write it in the comments. Its average density is 1.85 grams per centimeter cubed, corresponding to about half the lunar average density and 3 times lower than the terrestrial average density. This density value suggests a composition of approximately equal parts of rock material and water ice, with traces of volatile ices such as ammonia. The percentage of mass of ice present is 49 to 55%, while the rocky component is not known exactly, although it is probably similar to the composition of ordinary L and LL chondrites, which are characterized by a low content of metallic iron and a more abundant presence of iron oxide than H chondrites. Callisto's surface has an albedo of about 0.2. That is, it reflects 20% of the sunlight it receives. The surface composition is believed to be substantially similar to that of the rest of the satellite. Spectroscopic observations in the near-infrared revealed the presence of water-ice absorption bands at wavelengths of 1.04, 1.25, 1.5, 2.0, and 3.0 micrometers. Water ice appears to be ubiquitous on Callisto's surface, with a fraction of the total mass of 25 to 50%. The high-resolution analysis of the near-infrared and ultraviolet spectra obtained by the Galileo spacecraft revealed the presence of several non-frozen materials on the surface, such as iron and magnesium hydrosilicates, carbon dioxide, sulfur dioxide, and possibly ammonia and various organic compounds. The spectral data also indicate that the Callisto surface is extremely heterogeneous on a small scale. Small, bright areas formed by pure water ice are mixed with areas formed by a mixture of rock and ice and large, dark areas of non-frozen materials. Callisto's surface is asymmetrical, The hemisphere facing the direction of the orbital motion is darker than the other, contrary to what happens on the other Galilean satellites. The darker hemisphere seems richer in sulfur dioxide than the other, in which carbon dioxide is more abundant, an element that seems to be associated with many recently formed impact craters, such as the Loffen crater. Generally, the chemical composition of the surface, especially that of dark areas, appears to be similar to that of Type D asteroids, whose surfaces are covered with carbonaceous materials. Callisto is the most heavily cratered natural satellite in the solar system. Unlike neighboring Ganymede, which displays varied terrain, Callisto does not exhibit evidence of plate tectonic-like activity. Although these are two relatively similar objects, Callisto seems to have had a simpler geological history. In fact, the impact craters and rings concentric with them represent the only structures present on Callisto. There are in fact no large mountains or other prominent features. This was probably due to the nature of the surface. The sliding of ice in geological times has obliterated the craters and the largest mountains. Impact craters and multi-ring structures, escarpments, and associated deposits are the only major features found on the surface. Playing hide and seek at the bottom of never-illuminated craters would be one of the first hobbies of future astronauts who will colonize Callisto. What do you think? Write it in the comments. The surface of Callisto is dominated by two huge structures. Valhalla, the largest, has a bright central region 600 kilometers wide and concentric rings that reach 3,000 kilometers in diameter. The second, Asgard, has an external diameter of 1,400 kilometers. There are also chains, such as the Gipol-Katina, a long series of impact craters in a straight line on the surface. The origin of each of them is due to the impact on Callisto of objects captured by Jovian gravity and then fragmented by the tidal forces of the planet. The crust of the satellite has been assigned an age of about 4.5 billion years, thus dating back almost to the formation of the solar system, while the concentric ring structures have an age between 1 and 4 billion years, depending on the sources considered. Its average distance from Jupiter is about 1,882,700 kilometers, equal to 5 times the mean distance between Moon and Earth, and this makes it the outermost of the Galilean satellites. Its rotation is synchronous. This means that Callisto takes the time to complete a rotation on itself and in orbit around Jupiter. Specifically, it takes 16.7 days. In other words, on Callisto, a day lasts as long as a year. It follows that one face of Callisto is always facing Jupiter, while the other always faces the other side, as is the case with our Moon. Callisto travels an almost circular orbit and very close to the equatorial plane of Jupiter, with eccentricity and orbital inclination that undergo variations on a time scale of centuries due to solar and planetary gravitational perturbations. The eccentricity varies from 0.0072 degrees to 0.0076 degrees, while the orbital inclination is around 0.192 degrees. Callisto's dynamic isolation implies that it was never significantly affected by gravitational tides, and this affected its evolution and internal structure. Given its distance from Jupiter, the flow of charged particles belonging to the Jupiter magnetosphere reaching its surface is quite low and has had negligible effects on it, unlike what happened on the other Galilean satellites. The level of radiation on Callisto's surface is equivalent to a dose of about 0.01 rem per day, 7 times less than the level of radiation that the Earth receives. Here are some reference values of the radiation levels for comparison. 0.14 rem per day, normal dose at sea level, coming from cosmic rating and natural radioactivity of rocks. 50 rem per day, typical dose assumed for a 2.5-year Martian expedition outside the Earth's magnetosphere. This level of radiation increases the risk of developing cancer by 1% each year, more or less the same as induced by smoking. 75 to 200 rem in 30 days. The human body cannot repair cellular damage caused by radiation quickly enough. Nausea, fatigue, hair loss, malformations in children, cancer in later life can occur. 500 rem, fatal dose. Up to now, there has never been a serious medical emergency in space, partly for the short distances from Earth, partly for the periods spent in space largely not exceeding a few months. Conversely, common ailments from space, constipation, nausea, headache, bone pain, etc., have always been on the agenda and managed without major problems. In the case of long-duration missions, such as a trip to Callisto, common medical risks will be minimized by careful screening and vaccinations before flights. But the exposure to radiation, much greater than that which could be experienced on a trip to Mars, and to the reduction of gravity, as well as unexpected accidents, will constitute an unknown not yet well defined. According to the old protocols, a small mission of 4 to 6 people should include a doctor. However, in a larger mission of about 20 people, the presence of a paramedic or nurse is also desirable, which would also make surgical interventions possible. If you were to be chosen to colonize Callisto, what activities would you apply for? Write it in the comments. The idea of including a medical and surgical robot managed by a crew member trained with help from Earth is being studied. But here too there is a problem, namely the delay with which the signals travel due to the speed of light, which is very large but not unlimited. Communications between the ship's medical officer and the Earth would be interspersed with long waits. How would you behave in the event of an unforeseen event during a major surgery, while you weren't able to communicate with Earth in real time? Write it in the comments. In the hypothesis that a solution to these problems is found, where could a colony be created on Callisto? Considering that the basic idea is to try to exploit as much as possible the materials present in situ to build habitats and structures for a human crew, one possibly would seem to be to build the base inside craters rich in water ice, such as, for example, the aforementioned Valhalla. In this way, in addition to building materials for the colony, the crew could have an equally important resource, water, which could be obtained by melting the ice. The frozen water present at moon poles could also be used to produce oxygen for the crew. In practice, the water molecule would be split into hydrogen and oxygen. Hydrogen would be used as propellant, oxygen for respiration. In any case, the colony should be built on the face of Callisto from which Jupiter is visible, to allow an in-depth study of the gas giant and its surface details. In any case, before sending a human crew, it would be necessary to send habitat and supplies first. The colony would be built thanks to completely autonomous machinery and governed by advanced artificial intelligence systems. Once the base is built, other problems would arise. The first is energy supply. Due to Callisto's great distance from the Sun, roughly equal to 5 astronomical units, i.e. 5 times the average distance from the Sun to the Earth, it would be extremely difficult to use solar panels. An alternative could be the construction of a nuclear fusion power plant or the use of radioisotope thermoelectric generators, already in use on some space probes, such as New Horizons or the Curiosity rover. The second major problem is waste management and hygiene within the settlers' habitat. Unlike what happens on the International Space Station, where waste is stowed and burned upon re-entering the atmosphere in cargo modules, in a closed habitat on Callisto, contamination by waste materials could soon become a huge problem. As if all this weren't enough, it will be necessary to guarantee a certain comfort to the crew. In addition to the psychological aspect of being so far from the Earth, the astronauts will also need to ensure proper daily physical exercise to avoid muscle atrophy. Due to the very low acceleration of Callisto's gravity, it is very likely that astronauts will be prone to loss of muscle and bone mass. Don't forget to join the channel, leave us a like, and click on the bell. You will help us to make products of even higher quality.